Hello, grade 9s. In this lesson, we are going to look at how to write the equation of a linear relation when we're given a table of values. So we did talk briefly about developing equations on Friday before March break, but we're going to try to make it a little more formal today. So when we're doing an equation, we're going to do y equals our initial value, so that zero term, and then plus the rate of change, and then times our x value. So we're going to try that out. It says state the equation for each of the following. I have a table of values with x and y. So our x's are 0, 1, 2, 3, and our y's are 21, 26, 31, and 36. So in order for us to generate an equation, we need the initial value, and we need our rate of change. So basically, we need our zero term, and then we need what the differences are going up by every time. So for the initial value is our zero term, which in this table is actually here, right? It is 0 and 21. We look for the x value to be 0, and then the initial value is the y value that goes with it. So our initial value is 21. For the rate of change, we do delta y divided by delta x. Now, delta y are the differences on the y side, and delta x are the differences on the x side. So I need to actually calculate those differences to be able to do this. So 0 to 1, I added 1. From 1 to 2, we added 1. And from 2 to 3, we added 1. On the other side, from 21 to 26, you can do that on your calculator by doing 26 take away 21, but I added 5. And then from 26 to 31, we added 5. And from 31 to 36, we added 5. So on the x side, these differences are my delta x, or change in x. And on the y side, those are the delta y's, or the change in y's. So my delta y is going to be 5, delta x is 1, and 5 divided by 1 is just 5. So what this means is that our pattern has a zero term of 21, and then we're going up 5 every single time. So my equation is going to be y equals the starting amount, our initial value, so 21. So it starts at 21, and then we go up 5, and we don't just go up 5 once, we go up 5 every single time, so times x. So the last time we did it, I think we used n, because we did like the number of terms, but here I'm going to try to use y and x, and there is my equation. Okay, we're going to try the other table, same idea. So we've got x and y with slightly different numbers. The initial value should be the zero term in my table, and I do see on the x side that we have a 0. So my zero term is going to be 80. So my initial value is 80. All right, and then I need to find my rate of change. We do delta y over delta x. And I need to calculate my delta y's and delta x's. So to get delta y and delta x, we find our differences. So I look at what did I do to get from 0 to 3? I added 3. How did I get from 3 to 6? I added 3. From 6 to 9, I added 3. What about on the other side? How did I get from 80 to 77? You could do 77 take away 80, but I can tell that I subtracted 3. From 77 to 74, I subtracted 3. And from 74 to 71, I subtracted 3. So my rate of change is delta y. That's the change on the y side. So that's over here. That's -3. And then over delta x, that's the change on the x side. That's +3. Now, a negative divided by a positive makes a negative, and 3 divided by 3 is 1. So my rate of change is -1, which means for every 1 we go down on the x side, so I go up on the x side, we should be subtracting 1 on the y side. So my equation here is going to be y equals 80, and then -1 times x. I don't know why I just put a bracket there. I guess we'll go with it. There really doesn't need to be a bracket there. I just accidentally wrote one in. So you could write 80 minus 1x like that. Either one is fine. Okay? All right, so one last little thing before we end this part of the video and jump to the next one is, what's the point of having an equation, right? Why would I want an equation? So what an equation lets me do is calculate any entry that I want in the table. So let's say we wanted to calculate on the first one, entry number 3, right? I would do 21 plus 5 times, and then my x value, which is 3. So if I did 5 times 3 first, because order of operations says you multiply, and then add that to 21, you'll notice I get 36. Now that was in my table. What if I wanted to find term 100, right? All I'd have to do is put 100 in for x, so 5 times 100, and then add 21, and I would get my value of 521, right? So equations are really good because it allows you to calculate any value you want in the table without having to like fill in the table, with hundreds and hundreds of rows. Okay, so I will see you in the next video to try question number 2.